Okay, so all right, guys. You have stuff to do.
I've got a whole row of desks just for me. All right, round 3. Let's see if we can get it right. What? Yeah, you told me to rest my joints. I know what that means. Nah. You said we're a couple weeks behind on the Earth, a couple weeks ahead on the water. So I doubt we're going to be on the Earth tomorrow. Yeah, so actually I kind of like that because we're going to be more on the Earth, like, kind of when it becomes windy, which I actually rock with, because, like, the water's pretty good right now. Right. So like I think the training plan for this year is later. Do you think Crash is going to come later? Or still February? I think it's probably closer to mid or late February for the 3x3K. Probably, I'd say like mid-March. Yeah. I got it. No, because like I feel like
You guys take the worksheet out that you were given after the whatchamajigger.
So I'd say
Friday's
second
thing.
week of March at worst. That's where it was. I was wondering. At the worst to do. I couldn't do my math in my course. Like I lost my.
Okay, so
I'm joking. What's the?
here, Eric, be a doll. Hand me doll.
Doll.
Yes.
Objectified.
Thank you so much.
So guys, take the worksheet out.
I'm gonna text Coach Dan in your absence.
I almost out. Yes.
There you go. There you go. For you too.
Okay, how bad is the crash?
Not fast enough. It's okay. I didn't get very far either. Yeah. I did golf work. Added to that, right? Added to that.
Okay, so
And plus whatever.
is anyone else missing the worksheet from Friday?
Hey, if you're a TA, why am I doing this?
Oh, you need one?
Thank you.
Okay. So guys, and I want to hand back your thank you. Your free response that was the practice. And looking at how you guys graded things as an AP grader, y'all ain't gonna make it. You're like, oh, that's an 8 out of 5. I'm like, more like a 3. So, like, I'm not kidding. The L'Hopital's rule, you need to show that L'Hopital's applies. What is L'Hopital's rule? Liv?
It's the derivative of the top over the derivative of the bottom is equal to.
In what situation do we have it?
in 0 over 0 or infinity over infinity.
Okay, so when we're doing derivatives, when we're doing integration.
Oh, limits. Sorry.
Limits.
Important piece of information that I forgot.
You just took my pen.
You're right. I did.
Does that? Jeez. Okay, guys, L'Hopital's applies when there are limits. Some of you turned in stuff and you're like, oh, that L-hop thing, but no limits anywhere on the thing. Like, what? That gets like no credit. So please fix that by Thursday. So I will hand those back to I believe I posted the answer key. The answer key is hard to read and understand because since we've started grading remotely with AP, they put all the conditions like, well, Jackson, that you showed this, we'll give you the point, but that you didn't show this notation, we're gonna take that point, and they'll do all these things. And Noah wrote it a little bit different, but that one's acceptable, and they'll show all the shades of, and Logan did it this way, and that one's all right. So, the worksheet that you just got that's blank, did you do it over the weekend?
No, I
did.
didn't.
Okay, so it was handed out, but, okay. But I would like you guys to we're gonna work through this first one together. By the way, number 3 is really hard.
And then this one.
It's out there, the key is posted, but number 3 on there is hard. But let's look at this question first.
Wait, maybe we can do this.
We're gonna go through this one together. So Josh, it tells us here we have a graph of a differentiable function f. Is this a graph of f? Does it say on there that it's a? It's shown above.
Oh yeah.
I think it means above.
All this.
You don't want to practice it?
Carson, how do we do this one? It says h of x is the integral from 1 to x of f of x for the interval 1 to 7. How do I answer part A?
You would plug in 1 for x, so d on the interval 1 to 1, which is 0.
Perfect. And guys, I highly recommend writing that. H of 1 is, he said just plug in 1 for x. And write it down. The integration symbol, 1 to 1, f of x dx, or f of t dt, doesn't matter what letter you choose as long as it's consistent. And then he said the area under a dot, under a single coordinate, is 0. Great. Eric, how am I going to do this one?
Find.
We want to find h prime of 4.
Okay.
No, h.
Yeah. Okay. So, we know that is h. So h of x is equal to derivative.
Okay, wait.
The integral.
He just said something important. He said h of x is equal to the integral. So what is the next thing?
Well, h prime equals f of whatever.
Okay, this is a point out of the 9, which is a lot, because the integral of this is h, the derivative of it, h prime is f. So, Asher, this Asher, the other Asher is the other Asher here. Okay, so what is h prime of 4?
2.
Why?
H prime of x equals f. So 4 is 2.
Okay? So you can't just say h prime of 4 is 2. You need to say, how does, he read the answer of h off of a graph of f, so you need to, he did not do it. So you need to tie them together. If it asks you about h but gives you f, how do they tie together? Eric did that here.
And the graph is usually labeled, right?
The graph, like,
Has to
they
be
didn't, this is all they told you. And they're like, hey, the graph of f is above. Normally they have it blinking on here, like, this is f.
What do you mean blinking?
Well, they're normally like, this is the derivative, this thing here. They didn't this time. Morgan, did you have a question? Okay, so Lanham, what is part C asking us to do?
Asking to find when H is concave up.
Okay. When is H concave up? Logan, how do I find concavity?
When the derivative is increasing.
Okay, I have too many, so, and here's where they make a big deal about whose second derivative, because I have a function h and a function f, so whose second derivative? H double prime, f double prime, or something else? H. Okay, so you said when h double prime, when is, when H double prime is increasing,
It's positive.
is positive. Is there a difference?
Yes.
Yes. So which one is it?
Positive.
When H double prime is positive, H is concave up. Okay, so there's our justify. Oh, we haven't answered the question yet. Carmen, I have H, and Eric told us H prime equals F. How do I get H double prime?
You take the derivative of the double derivative, so it'd be, you look at the slope of f of x, or the derivative of x.
Okay, so H prime of X is F, H double prime is F prime, which Carmen just said is the slope of F. So Iris, looking at all the stuff they gave us and this information, when is H concave up? So, safer to leave those brackets round than, yes. I believe they will accept it with square here, probably on all of them. The answer key, I'm fairly certain will have open round ones. And the point is, right here, if I say it's concave up there, don't I also need to say it's concave down there? Like if I'm gonna do a square bracket, I need to do it
Well,
both
I
directions.
meant square bracket on the one and on the set.
Because it's their endpoints,
But
they won't take off for that. But they will have it on the answer key
It can't be
probably open.
concave up or down at any point.
So at the end point to show concavity, you need to know what's on the other side. It didn't start. So it's safer to leave them round. But I don't believe they would take off.
Yeah.
Okay, so double prime is when it's concave up when H double prime is positive, which Iris said is 1 to 3 and 6 to 7 because that's when the slope of F prime is positive. Good? Like after a while, these get hopefully easy, like they become predictable. But you guys need to be able to make the connections between the first derivative, second derivative, and that. And you need to remember where are absolute maximums, where is concave up. Like you need to remember all that stuff from chapter 4. All right, part D. Well, what is part D asking us to do?
It's asking you to find the minimum for H.
Oh, bummer. Okay, where are the minimums going to be?
It's gonna be where the concavity switches from negative to positive.
With the
Not
concavity.
necessarily concavity. Sam, what do you think?
Where the derivative of H equals 0.
Okay, hold on.
But, and then that's what like we learned last semester, but looking at this, I don't think that's right. But the integral can be, like it goes below.
Okay,
It goes below the x-axis.
That's
hold on.
Right, so we're looking at.
Okay,
We're looking for one of these switches from negatives to positive.
all right. So Mael is saying, first, Sam, you said to find critical points. Critical points are where maxes and minimums can happen. They don't have to. It could be a change in concavity. So all the critical points are where the first derivative of the function we're talking about, so h prime, where it changes sign. One place it changes sign here is at 5. And Mael, is that a maximum, a minimum, or a neither?
That's a maximum.
It's a maximum because the first derivative, it was going up, 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 and then it's coasting, and then comes to a stop in its velocity or whatever, and comes back down. This is a maximum. It is asking us for a minimum. Okay, so where else can maxes and mins happen? So, Paul, what'd you say? Endpoints. So, Noah, what do you think?
I was gonna say 7, but you're not sure if it like bounces on the x-axis or it crosses over.
Um,
There's nothing after it.
Yeah, there's nothing after it. So Where is, oh, and it says it's minimum. Does that mean absolute or does that mean like any minimum?
Absolutely.
Absolute.
What?
Absolute. So it's unfortunate. Yeah. Bad wording.
Or are we gonna solve
So,
it?
well, what
Do
you,
wanna
I thought
solve
you were going to answer the question.
Yeah, I was gonna solve it. So
Okay, what is
plug
it?
in like it could either be 1 or 7, right? So the two endpoints, right? And you can do the integral of h of 1 to 1 of f of x, that's 0. That's the point, right? And then you can do the integral of f from 1 to 7. I don't know
Okay.
what it is, but it looks more than 0.
So Eric is saying, you know what, we need now to test these ends. And the other critical point was a 5, which we know is a maximum because that's what Mael said. The first derivative went from positive to negative. Carson, what did you say our answer was in the very beginning for part A?
Each of 1 was 0.
H of 1 was 0. So Eric said, find those values. Well, we found one of them already. And then the integral is the area under the curve. So how much area under the curve did I get to at 5? Well, I'm going to just count some blocks. 1, 2, 3, kind of 4, 5, 6, 7 and a bit. It's something. And then Isaiah going from 5 to 7, how much stuff does that look like? 1-ish, maybe a little more than 1. So, and is it positive or negative? So negative. So so what's my end value approximately at 7?
6.
Like 6. So what is the overall maximum? Or sorry, minimum?
0. This is kind of fun.
Wait, but why wouldn't that be negative?
Hang on. Are we at X? I can't see the problem anymore. Are we X's or T's?
Wait, where do we get to the negative?
T's.
So negative, it's like approximately.
And it says find the X value.
It's the each of 6. It's the area of the curve from 1 to 6. Yeah, 1 to 7. 1 to 7.
Okay, Mael, what's
So they're both endpoints.
okay?
Well, there's two.
Both
Starting point
minimums.
is the endpoint.
What is
Which
the
one's lower?
which one is lower? So starting here. So just a hint. Part A was a hint to assessing your answer for part D. So you started off at 0 because Carson said area under a dot is 0. And then we walked forward. We walked forward for a long time. We walked forward, gathering all this distance. And we're like, okay, tag, hit my point, and then I turned around. Did I end up back to where I started? I did not walk backwards enough yet. The area under the curve did not counteract all of this. So Mael, your minimum was when you started, which was at 0. And I'm going to show you their reasoning in a second. And they just drew bubbles, and they're like, this big fat bubble is bigger than that bubble, so the beginning is the minimum. You know? All right. So here's what they say, and I don't think I have the point count down here because they did not publish them at the time. So 1 point for the first question. Cool. That's a freebie. This now, part B, would be 2 points. 1 to make the connection of h prime of x equals f of x, and then to be able to read the value of 2 off of the graph. So that would be 2 points. And then Iris would have gotten a point for telling us the correct intervals where it's concave up. And I think it was Logan was the one that said concave up is any of these things. But she had said when the double derivative is positive, and not double derivative, but h double prime of x. You've got to be specific about saying, is it h of x that we're talking about or f of x? And then get this. Minimum at x equals 1 because this is a big fat bubble and this is a little tiny bubble. But this does have some of Eric's reasoning that, and Mael said the maximum was at 5. H increases over this bit, then decreases, so the minimum's at an endpoint. And Eric said we gotta check the 1 and check the 7. And in doing that check, at 1 we were at 0 and stuff. Okay? Issues, comments, questions. Okay, I'd like you guys to try the second one more or less on your own. Yes,
This is from
Lynn?
1996.
I was wondering, when we were talking about the last question D, it asks us to justify our answer. Can we just justify, like, to what extent do we have to justify it, and do we have to write anything? Because, like, I just
See the words, like you wrote too much, like you're writing too much. Use the math to support your answers, but you don't need to say, and then we do the derivative, and then, like, just not as much.